Dear friends, hoping that you are fine and preparing well for your upcoming exams with the blessings of Almighty Allah. And right now, we are starting to solve paper 4, 0625, paper 4, variant 2, and this is in February, March 2016. And as usual, some common questions, common things. Time allowed is 1 hour, 15 minutes, which means 75 minutes total time, and 80 marks are there. And almost all less than a minute per mark the time we have. So we have to be very much fast and accurate. And value of G, actually it is old paper. Value of G in these years was 9 point, it was 10 meters per second squared. But if we have to use in this question paper this value, so we will be using as 9.8 meters per second squared, so that we are in practice for our external exam. So the question number 1 starts from a driving instructor gives a student sudden order to stop the car in the shortest possible time. Figure 1.1 shows the speed time graph of the most of the motion of the car from the moment the order is given. Now, this is a speed time graph. Units are good. They are meters per second. Meter per second here, and time is in seconds. So nice. Question is, the order to stop is given at t is equal to 0. State the speed of the car at t is equal to 0. So c times 0 is over here. This is the speed. 10, 11, 12, 13, 14, 15, 16, 17, 18, 20, 19, and 18. Anyway, it's 18. So straightforward answer, 18 meters per second. Suggest why the car continue to travel after travel the speed for 0.9 seconds. See, till 0.9 seconds, my dear friends, still here, and this is 0.9. For 9 seconds, we can see that the speed of the car does not change. Actually, the brakes are applied after 0.9 seconds, and then the car starting to decelerate. So reason for that, it is the reaction time error. Reaction time, because human beings, we are always taking some time to react a question. So the driver, he took 0.9 second to start pushing the brakes. So we will say 0.9, it is due to, okay, simply we can write that it is due to the human reaction time. Human reaction time to respond. Next is the deceleration of the car between 0.9 and 4 seconds. Deceleration, as in some previous papers we have discussed, deceleration means it is a type of acceleration, and but it is a negative acceleration. Same equation, calculated mean formula and same unit. So even before solving, I'm writing the unit here is meters per second square. Acceleration equal to v minus u over t, or you can use acceleration is equal to gradient of the graph, that is equal to y2 minus y1 over x2 minus x1. So any one of these two you can use. And what we are going to do, 0.9 and c. Car starts to decelerate from here. So this is the initial velocity, which is 18. So u is equal to 18. It stops over here. That is v equal to 0. So that is also equal to y2. And this value is also equal to y1. Then time interval, that is from 0.9 to 4.0, that is the time, or even we can call it x1 is equal to 0.9 and x2 is equal to 4. Anyway, we can move and we can get. So if I'm using the formula for A is equal to V minus U over T, V is 0, U is 18, and T is 4 minus 0.9. So as we are simplifying it, we are getting the answer equal to minus 5.806 minus 5.806. We are never going to write this much long answer. Deceleration itself includes the negative. So here simply we are writing 5.8 meters per second here. The answer. Now, the total distance traveled by the car from t is equal to 0 seconds. From t is equal to what? 0 seconds. So now, what to do? Whenever velocity time graph is given or speed time graph is given, we are using, dear friends, the area under the graph. What we are using? We are always using the area under the graph. Roughly, I will now explain. You see, area under this graph is now, by the way, this trapezium. Roughly, I'm making it so that you can just differentiate it. This is a trapezium. Now, what is a trapezium? Trapezium is a geometric shape which has four sides, and two of them are parallel to each other. Now, see, this is, let's suppose, side A, which is equal to 4.0. This is side B up to here, which is equal to 0.9. And A and B are parallel to each other. See, B is going parallel to A. So these are two sides. And also, there is one thing more, the height of the trapezium are more suitable for understanding. This is the distance between the two parallel sides from here till here. So H, that is equal to 18. Now, all the data is with us. A is with us. This is one of the parallel side. B is with us, which is the second parallel side. Their numerical values are there. A is equal to 4, B is equal to 0.9, and height. The distance between the parallel sides is 18. So the distance is equal to the area of the trapezium. The equation for area of the trapezium is 1 over 2 A plus B, sum of the parallel sides times H. So now 1 over 2 times A is equal to 4 plus B, which is equal to 0.9 times H, which is equal to 18. See, again, A is equal to 4, B is equal to 9, and H is equal to 18. So these values I have placed into the equation, and I'm getting the answer after the calculation equal to 44.1. So here we can simply write 44.0 and write in meters because distance is in meters. Then, my dear friend, describe and explain a danger to a driver of not wearing a seat belt. Danger not wearing a safety belt during a sudden stop. Now, always be very careful. This is basically related to the momentum stuff, but a common observation that when the brakes are applied to the car comes to rest. Brakes are not applied to the driver or the passenger on the front seat or on the back seats. So when the brakes are applied, car comes to rest. The driver, he will keep on moving forward. So if no safety belt is used by the driver, so he will continue moving forward. He may hit the dashboard, he may hit the windscreen, he may hit the steering wheel. Any one thing we can write. So the answer, we will answer it in a way that as a result of sudden stop, so we will say the driver continue to move forward. The driver will continue to move forward. This is the first mark. Will continue to move forward, and what will be the result? And he will hit windscreen. Let me write like this. You can say steering wheel, you can say dashboard. This is the second mark. So he will hit the windscreen and he will hurt himself. So this is the answer here for 2 marks. Of course, you are not going to write these one. I'm just dividing the marks, how they will be awarded in exam. Let's move to the next question. Still, we are talking about the general physics. Next question is figure 2.1 shows. Figure 2.1 shows a hammer being used to drive a nail into the piece of wood. So you can see here hammer about to hit the nail, and which is supposed to be driven into the wood. Mass of the hammer 0.15 kilogram. Speed of the hammerhead when it hits the nail is 8.0 meters per second. Time for which the hammerhead is in contact with the nail is 0.0015 seconds. So the hammer head stops after hitting the nail. It means, my dear friend, there is final velocity which is 0. Initial velocity is this one, time interval is this one, and the mass is this one. Now calculate the change in momentum of the hammerhead. Change in momentum. So change in momentum, we can denote it by delta for change and P for momentum. So mv minus mu. So we can write m common, then v minus u. Then, my dear friends, this means mass which is 0.15 times v is 0 and u is 8.0. As we will simplify, answer will be minus 1.2. Now remember, just like deceleration answer, we are never writing negative. Similarly, change in momentum, we are also never writing negative. If the answer is negative, we can directly write it plus 1.2 change in momentum. Formula is unit is kilogram meter per second. The reason, because the equation for momentum is mass times velocity. So mass is measured in kilogram and velocity is measured in meters per second. Try to use a smaller value, smaller letter v, because capital V is either for volume or for volt or for voltage, so not for velocity. So 1.2 kilogram meter per second. The point to remember this negative sign. When it is change in momentum, negative sign we are ignoring. We are not writing negative sign in the case of change in momentum. Now, next is state the impulse given to the nail. Now, my dear friends, impulse has two equations. Impulse is equal to either force times time of contact basically, and also impulse is equal to mv minus mu. In other words, change in momentum. It is only one mark. So directly, whatever is the change in momentum, that is also the impulse. So kilogram meters per second. If you are writing the unit from this one, so even you can write the unit 1.2. It can also be Newton second, no problem from unit point of view. If you are following change in momentum, kilogram meter per second, if you are following force times time, then Newton second, no need to worry about. Then calculate the average force between the hammer and the nail. So equation we know from Newton's second law of motion in terms of momentum, force is equal to change in momentum per unit time. And we know change in momentum is 1.2. And time, my dear friends, is very short, 0.0015. Here is the time, 0.0015. And as we simplify it, we are getting the answer equal to 800. And writing here only 800 will not be enough because it is a force and force is measured in newtons. I'm sure these things are clear to you people. In case of doubt, feel free. You can ask me in the comment section on the channel. Now the next question that is talking about on figure 3.1, draw a graph of extension against load for a spring which obeys Hooke's law. So 1 mark. What is Hooke's law? Actually, the statement of Hooke's law means extension is directly proportional to force within the limit of proportionality, and you are not supposed to use extension is directly proportional to force or load with an elastic limit. Elastic limit is no more with us in the syllabus. Before elastic limit, there is another limit known as proportionality. So we are using now proportionality limit. Not only for this question, always remember when two quantities are proportional, I mean directly proportional, and we have to show it with the help of a graph between those two quantities, then the graph between them is a straight line and it is passing through origin, like this. Graph is a straight line and it's passing through what? Origin. And you are not supposed to do this stupidity. This will be considered wrong. Why it is wrong? Because your graph is going out of the axis of the mean. It is not possible. So this is wrong statement. What to do? Graph straight line passing through origin, but within the load and extension axis. So the correct answer right now it is shown in front of you. So this one is correct. So you have scored 1 mark. Next is, state the word used to describe the energy stored in a spring that has been stretched or compressed. Very simple. This is a straightforward question. So the energy stored in a stretched object or compressed object within the limit of proportionality, that will be strain energy in one word, or you can say elastic potential energy. In both the ways, it's okay. Strain energy, or you can say also elastic potential energy. Now, next question is a bit tricky and it's for 4 marks. Figure 3.2 shows a model train traveling at a speed v, approaching a buffer. Now, this is a buffer. What is a buffer? In general, in every country where there is a railway system in action, on the main track, especially where there are stations, platforms, and the braking system of the train is failed. So they are always directing the train on a separate track, which is ending with a buffer. Now, what is this buffer? Very strong, rigid object. I mean, metal poles, they are very strongly placed inside the ground. And then, like, there is a very strong spring also inside here. This is a spring, it is mentioned already that it is a spring. So now what happens as this train, sorry, I'm saying again in car, train's brake system will be failed. So this will be moving on this buffer on a track, not on the main track, but it will be directed towards the track, which is ending with the buffer. So it will be no more accelerating. The driver is no more accelerating this train. So it is slowing down, and ultimately, as it will hit the spring, so its kinetic energy will become zero, spring will be compressed. So all the kinetic energy losses will be equal to gain in strain energy. And as a result, without the least damage, the train will come to rest or a halt, and a big disaster will be saved, or it will be stopped to take place. Anyhow, so now let's see the data. The mass of the train is 2.5 kilograms. So of course, it is a model train. Is stopped by compressing a spring in a buffer. That's what I was telling you. So when the train is stopped, it means kinetic energy is becoming zero. So kinetic energy is lost, and it is compressing a spring in a buffer. So it means that kinetic energy is converted to strain energy of that stored in that spring. After the train has stopped, the energy stored in the spring is 0.48. So you can see elastic potential energy. The spring is 0.48. Calculate the initial speed of the train. No worries at all. Very simple. No law of conservation of energy says we will write it like this, that loss in kinetic energy will be equal to gain in strain energy, or you can say elastic potential energy, both the ways it's okay. Now, equation for kinetic energy 1/2 mv squared is equal to just this value is with us 0.48 joules. Now, 1/2 times mass is 2.5 kilograms. Speed we need to find, so 0.48. Then, my dear friends, we can write v square is equal to 0.48 times 2. 2 is being divided on the left hand side of the equation, so right side it will be multiplied. Simple mathematics. 2.5 is being multiplied on left hand side. On right hand side, it will be divided over 2.5. We don't need square. We need basically speed only. So the square root will cancel this. And as we will simplify, answer will be 0.619. So we can write it 0.62 meters per second. So this will be the mechanism to solve this question. Important, a bit tricky this part. Otherwise, rest of the part is okay. Now I think our general physics portion is done, and we are moving towards now thermal physics of this paper. The source of, and question number 4, the source of solar energy is the sun. Source of solar energy is the sun. Tick the box next to the those sources for which sun is the main source of energy. Now, answer is coal. Your tick should stay within the block. Coal. Why? It is a fossil fuel. And what is a fossil fuel? Fossil fuels are the remains of dead animals and plants buried millions of years ago. So when those plants and animals were alive, so they were wholly solely depending on this solar energy. Even right now, we are depending on solar energy. Plants are depending on solar energy for a phenomenon to make their food, photosynthesis. And plants are important for us. So coal, all the fossil fuels, they are dependent on not only coal, but all the fossil fuels are dependent on sun. I mean petrol, natural gas, and coal. Geothermal law, it is some energy, heat energy within the rocks deep down into the earth. Hydroelectric, yes, this is also based on solar energy. Why? Because the infrared radiations, IR radiations from the sun, they will evaporate the water from water masses like oceans, lakes, rivers, forming the clouds. And on condensation, these clouds will cause the rainfall, also snowfall in winter. So that water is stored within the dam. I'm not going into that much detail, but dams are also in hill stations where there is a high rainfall or snowfall during the whole year. So that water which is stored behind a dam to turn on the turbine and in the end to turn on the generator to generate electricity, that is also indirectly linked with the solar energy. And the last one is wind. Nuclear is no, because nuclear is also because of the heavy metals like uranium, radioactive materials, sorry, like uranium and radium and like this. So they are also not dependent on sun. So coal, hydroelectric, wind, they all depend on sun. Two more are depending on sun from your syllabus point of view. Let me write them. Like two more are there. They are also like, I can say biomass. Even you can find it in exams like biofuel. One more is there, and that is itself directly solar energy. These two are also depending on solar energy. And one more is there which is not depending, that is tidal energy. Tidal energy, it is not depending, so it is blank. So please memorize this. This will be helpful for you because it is a repeated stuff in exams nowadays. So this, which are within the box and tick, they are all depending on the solar energy, on the energy from the sun. And which are boxes without tick, they are, it means these are the sources of energy, which resources of energy you can say more suitable, which are not dependent on the sun. Let's move forward now. Next part is figure shows a solar water heating panel on the roof of a house, and plants are copper tubes painted black. Now he's saying cold water flows into the copper tubes, which are heated by the solar radiation. Hot water flows out of the tubes and is stored in a tank. Explain why the tubes are made up of copper and are painted black. Very simple, straightforward question. A recall memory, I would like to say it. So, copper is a good conductor of thermal energy. And then painted black, you can say black color is a good absorber, is a good absorber, good absorber of radiation. So like this we can answer it. Now, my dear friends, next is, so this is 1 mark here and 1 mark for the black color. So 2 marks, very simple, straightforward question. In 0 0.5 seconds, time is mentioned, 0.019 kilogram of water, mass is mentioned, flows through the tubes. The temperature of the water increases from 20 degrees Celsius to 72 degrees Celsius. From here, we can get the change in temperature. The specific heat capacity of water is 4,200 joules per kilogram per degree Celsius. Calculate the thermal energy gained by the water in 5 seconds. Gained by the water in 5 seconds. So, my dear friends, time is mentioned. And how much is the time? 5 seconds. Mass is given. This will help us to find out the change in temperature. Specific heat capacity is given C, and time is given. So the energy gain. So we know E is equal to MC delta T, and I'm telling you to memorize it in terms of MCAT. E is equal to MCAT. So mass is given, which is 0.019. C is told, which is 4,200. Change in temperature, that will be equal to 72 minus 20. As we are simplifying this all, multiplying, we are getting the answer, my dear friends, which is equal to 4149.6. 49.6. I cannot write this one long answer. I can allow to write minimum to maximum 3 significant figures. So simply I can either write it 4150 joules, or simply I can write 4.1 times 10 raised to power 3 joules. Don't forget to write capital J. Okay. Now, next question is, the efficiency of the solar panel is 70%. Calculate the power of the solar radiation incident on the panel. So here you need to be very careful. See, we have calculated here energy, and here they want initial power. So we need to convert the energy up there into, this is output energy, and we need to find it, we need to convert it to output power. And why it is output power? Because power supplied or power incident on the panel, that we need to calculate. So this is the output power. So what we can do, and we know the formula for power, it is rate of transferring energy. So energy over time. We have energy, we have time, no problem. So, but let's start first of all with the equation of efficiency. Efficiency equal to useful power output over total power input times 100%. Now, my dear friends, efficiency is given. How much? That is 70%. Useful power output, energy is there with us, which is 4149.6. 4149.6 divided by 5, which is the time. Why divided by 5? Because power is equal to energy over time. This is the useful output power. Power input we need to calculate times 100%. So when we are making power in as the subject of equation, so answer comes to be, okay, I can write here again 4149.6 divided by 5 over 70% times 100%. When I'm doing so, I'm getting answer 1185.6. So I can round it off to the nearest 100. 1200 watts is the answer for this question. Or you can write 1190, but not 1185.6. Minimum 2, maximum 3 significant figures we can use. Okay, my dear friends. Next is now a very tricky question. And not only in paper 4, it is also common in paper 6. Now here, a student carries out an experiment to find the relationship between the pressure P and the volume of a fixed mass of a gas. And by the way, we know this relationship very common, that is in Boyle's law. As the pressure on a gas is increased, its volume is decreased at constant temperature. So now there is what? A table contains 4 sets of measurements. And what are these measurements? See, this is pressure in kilopascal and volume in centimeter cube. He's saying use the data in the table to suggest a relationship between the pressure and the volume in this experiment. Explain how you reach your conclusion. Now here, I will be explaining you here something, my dear friends. Oh, so like I told you, pressure is inversely proportional to volume. And if we have to prove it from a set of data, this implies that the product of pressure and volume, it should stay constant. If two quantities are inversely proportional, always remember from a set of data given, and we have to prove it, then the product of those quantities should be constant, like we will apply it here. And if two quantities are directly proportional, like my dear, we know extension is directly proportional to force, and we have to prove it from a given set of data, then ratio of those quantities should be constant. Like either we can say f over x or even x over f, doesn't matter. But more suitable if f over x, because that is spring constant. It should be equal to what? Constant again. It should be equal to constant. So what is the conclusion? For two quantities to be inversely proportional from a given set of data, we have to decide the product of those quantities should be same. And for two quantities to be inversely proportional, product should be constant from a given set of data. And for two quantities to be directly proportional, the ratio of those quantities should be constant for the given set of data. Now here we will use the product. Now let's see, product of these quantities is same. PV is equal to, if I'm doing 250 times 30, I'm getting directly 7,500. So I have used this one first. Now I'm using this one. 750 times 9.8, I'm getting, I think, almost 7,600. I'm getting how much? When I'm multiplying them, I'm getting equal to 7,600. I'm not writing the units, just numerical value. Units will be same. Then if I'm trying last value, this one, see, this product is giving me, see, 1000 times 7.6. This is directly equal to 7,600. Now check. Now this data shows that PV product is nearly equal to what? Constant. So this implies that pressure is inversely proportional to volume. See, 7,500. 7,600, 7,600. Even if you will check these two, answer is also 7,600. So out of four values, three values are exactly 7,600, one value is 7,500. So it means the product of pressure and volume is almost constant. So the pressure is inversely proportional to volume. And there is also, these are gas laws, one of the gas laws when they are talking about three physical quantities which are dependent on each other, like pressure, volume, and gas, like here. And if two quantities are in proportionality, like in this case, pressure is inversely proportional to volume, the third quantity, temperature, it will stay constant. And that is their next question. State the property of the gas apart from the mass that remains constant during the experiment. So of course it is temperature of the gas. It is temperature of the gas. Next is now, the lake is 5 meters deep. The density of water is 1000 meters cube, kilogram per meter cube. Calculate the pressure at the bottom of the lake due to this depth of water. No atmospheric pressure is mentioned here. Pressure in fluids is equal to rho GH density times D times depth. Now see, this is the depth. This is the density. So simply 1000 times 9.8 times 5, we are getting the answer equal to 4,900. Oh, 49,000, sorry. So you can write also 4.9 times 10 to the power 1, 2, 3, 4. 4 pressure is measured in pascals. Now, this next one is a bit tricky, and you have to make use of your full brain in terms of the concept of pressure. A bubble of gas escapes from the mud at the bottom of the lake and rises to the surface. Bubble of gas initially was at from the mud at the bottom of the lake, then rising to the surface. Now, what happens to the pressure? Wait a minute. Let me first explain. We know pressure influence increases with depth. So when that bubble of gas was at the bottom of the lake, maximum number of water molecules were above it. So more molecules, more mass, it means more force, it means more pressure. So pressure was higher when the bubble of gas was in the mud at the bottom of the lake. Now it rises to the surface. So it means depth is decreased, number of molecules of liquid on it, water on it decreased, mass is decreased, force is decreased. So as a result, pressure is also what? Decreased. So just we studied pressure is inversely proportional to volume. Now, place one tick in each row of the table. What happens to the volume, the mass, and the density of the gas in the bubble? Assume that no gas or water vapors enters and leaves the bubble. First of all, volume. We know, just we discussed up that pressure is inversely proportional to volume. So when mud is rising up, so volume is increased, so pressure will be what? Decreased. Pressure will be decreased. So volume of the bubble increases. Mass of the bubble, as it is mentioned, no gas or water vapors enters the or leaves the bubble. So it means it stays the same. Density now. What is the relationship between density and volume? Density is inversely proportional to volume when the mass is staying same. Now volume is increased, so density will be decreased. Density of the bubble decreases. So this way we can follow these two marks and we could score these two marks. Okay, dear friends. Now this is very simple. Figure 6.1 represents wavefronts of a sound wave. The wave is traveling at constant speed. So displacement of the particles here and the distance along the wave is there and different points. On figure 6.1, mark with the letter X the corresponding distance representing the amplitude of the wave. Amplitude is the maximum displacement on either side from the undisturbed position. See, this is the rest position or equilibrium position, undisturbed position. So of course, from here till here, this is the amplitude. We will mark it with letter X. Then amplitude is the maximum displacement from the rest position of the wave, equilibrium position of the wave to the either side, either top or bottom. Even this one will also be amplitude, but we are not given that option. Then label with the letter Y the marked distance corresponding to the wavelength of the wave. Wavelength, length from one crust to the next crust, that is not marked here. But wavelength is also length of one wave. See, starting from here, one trough and then one crust. So it means it is the distance from here till here. Y, this one distance. Very simple. Now, state what happens to the amplitude of the wavelength of the wave if loudness of the sound increased at constant pitch. Loudness of sound is directly proportional to amplitude. So if the loudness of the sound is increased, so amplitude also increased. What about the wavelength? See, let me write pitch is directly proportional to frequency, but also pitch is inversely proportional to wavelength. Here we have to use this relationship, inversely proportional to wavelength. Constant pitch, it means if the wavelength was more, pitch was less. If the wavelength was less, pitch was more. Now pitch is constant, so wavelength will also stay what? Constant. Now next, pitch of the sound is increased at constant loudness. Now loudness depends on amplitude. Amplitude is constant. So for loudness to be constant, amplitude should be what? Constant. Because loudness is directly proportional to amplitude. Very simple question, so I'm not taking a lot of time. Wavelength now. Sound, pitch of sound is increased. If pitch is increased, it means wavelength should be decreased. So it is decreased. Okay. Now, a ship uses pulses of sound to measure the depth of ocean beneath the ship. A sound pulse is transmitted into the sea and the echo from the seabed is received in 54 milliseconds. The speed of sound in seawater is this. Calculate the depth of the sea beneath the ship. Oh, my dear friends, first of all, echo. This is very important, going and coming back. This is 54 time. That will be 54 times 10 raised to power minus 3 seconds because this ms, it stands for here a submultiple milliseconds. And milli means always 10 raised to power minus 3. It is meter, millimeter, so 10 raised to power minus 3 meter, millisecond, so 10 raised to power minus 3 second, and so on. And the speed of the wave in water is given. Now, question is there is echo. It means sound from the bed, from the bottom of the ship goes to the bed of the ocean and then comes back. It has to travel double the distance. So when there is echo, we are not using speed is equal to distance over time. We are always using 2 times distance over time. We need the depth, so make d as the subject of equation. So cross multiply 2d is equal to v times t. Make d as the subject of equation, so v times t over 2. Now place the values. 1500 times t, which is 54 times 10 raised to power minus 3 over 2. As we are simplifying this question, we are getting the answer 40.5 meters. So we are getting answer equal to 40.5. It means we can write even 41 meters or even 40 meters. Anyway, it is correct. Okay, my dear friends. Echo, reflection, bouncing, not only sound for light, for a tennis ball hit by a racket, wherever. So echo, we are not using the formula of speed, simple conventional d by t. We will do it. V is equal to 2 times distance over time. Now, explain what is meant by total internal reflection. One mark, a very simple definition we will write that total reflection, it means that all the light is reflected back. Is reflected back into the denser medium. Into the denser medium. Next is critical angle, also a very common definition being asked in exam. So you should memorize it very well. So critical angle, it is an angle of incidence in denser medium. Incidence in denser medium whose corresponding angle of refraction corresponding angle of refraction is equal to what? 90 degree. And it has particular value for different materials. Like for glass, it is 41.8. We are using it as 42. For diamond, it is only 24 degrees. And for water, pure water, it is, I think, almost 49 degrees. Now, this next question is simple, very simple question. So the speed of light in air is this, and speed in glass is this. Calculate the refractive index of the glass. In air, denoted by C, speed in glass or any other medium denoted by V, refractive index by N, and N is equal to very simple formula C over V. So it means values are with us 3.0 times 10 raised to power 8 meters per second over 2.0 so times 10 raised to power 8 meters per second. Now my dear friends, answer is the meter per second cancel with meter per second, 10 raised to power 8 with 10 raised to power 8, 3 divided by 2, it is 1.5. And there will be no unit, and it is also the answer as we are used to say if why refractive index is having no unit or magnification is also not having a unit in physics of waves for some in terms of images. In both the cases, or any physical quantity in physics which is not having a unit, so only answer is because it is a ratio between two similar quantities. Like in this case, refractive index has no unit because it is a ratio between two speeds. So meter per second is cancelled by meter per second. Next, so that the critical angle for the glass air boundary is 42. Answer is given. There is again another formula. 1n is equal to 1 over sine angle C, critical angle. So we need critical angle to cross multiply sine angle C, that will be equal to 1 over n. Then angle C is equal to sine inverse 1 over 1.5. And as we simplify it by making use of calculator, we are getting it equal to 41.8. So that is equal to 42 degrees. Now, on prism, on figure 7.1, sorry, draw carefully without calculation the continuation of the ray through the prism and into the air. Through the prism and into the air. So here, first of all, check this ray is at 90 degree. And if it is at 90 degree, it means it is not going to change its direction. It will keep on moving forward straight. So first mark is given to the student when the student is drawing this line straight. Without any change of direction, put an arrow. When you did this, you have scored 1 mark. Now second mark will be given to you when you are drawing here a normal, because without normal, we cannot assess any angle in physics of waves. So roughly, this is the normal at that point. So whatever is the angle of incidence here, same will be the angle of refraction. No need to write any number. Angle of reflection, sorry. So how it will be? It will be roughly something like even in exam you can use a protractor, but right now I'm doing it roughly this way. So when you did this, you have scored the second mark. Now the third point was out into the air, continuation of the ray throughout the prism and then into the air. Now into the air. Again, we need to draw a normal here at this point. So now it will be moving from glass to air. It will bend away from the normal. So again, we need to draw a normal roughly here. This is the normal, and I can make without any angle measurement but bending away from the normal. This ray will take this way. Now, my dear friends, this is the third mark for you people. So 1, 2, and 3 marks, and we did not calculate. By the way, this angle and this angle, they should be equal always because it is total internal reflection taking place over here. Okay, my dear friends, let's move forward. And now electricity questions are there. So question number 8, figure 8.1 shows 3 lamps and a fuse connected to a power supply. Fuse is always connected in series. It is a weak link between the circuit in series. So if the current exceeds its rating, like it is a particular rating. A 2 ampere fuse like this one is 2 ampere fuse. So a 2 ampere fuse can allow maximum 2 ampere current to flow through it. If the current will exceed from this value, this fuse wire, weak link inside the fuse, it will be melted, circuit will be broken, and as the fuse is connected in series, so all the components will be disconnected, no current will be flowing, and we will be saved from a major disaster or a loss. Now these lamps are in parallel to the battery. So see, each lamp is labeled 220 and 40 watts. It means they are all identical fuses. Calculate the current in each lamp. Very common equation nowadays to calculate current. Power is equal to current times time. So from here, if I'm making current as the subject of equation, so power over voltage, it means 40 over 220. As we are simplifying 0.1818, we cannot write this much big number. So 0.18 amperes is the answer. That is the current in one lamp. Now, my dear friends, the current in the fuse. This is only one mark. And if you ask me, I will be writing 0.18 plus 0.18 plus 0.18, and directly answer will be 0.54 amperes. Even if you are writing the answer directly like this, you will score the credit because only one mark. But if it is for 2 marks, then what to do? See, this fuse is carrying total current. Let it be I1, this is I2, and this is I3, because in parallel combination, current is not the same. So the total current in the circuit, just for understanding, I'm explaining. Otherwise, you can write directly this answer. 1 mark only. I1 plus I2 plus I3. So this implies that I is equal to simply the sum of these currents. And only one lamp current we have calculated, and all the lamps are identical. So the same answer will be there through the amount of current through each lamp. Now, this is simple, just not physics, a simple mathematics. Total number of lamps all in parallel that could be connected without blowing the fuse. So here simple, the rating of the fuse is 2 amperes. So divided by the current of 1 ampere, one lamp. See, current in one lamp is this, and the fuse rating is 2. So 2 over 0.18, and as we simplify, 11.1111. So maximum number of lamps are 11, which can be connected in parallel without the fuse is blowing, and the circuit is operating normally. Now here, after a very long period of use, the wire filament of one of the lamps becomes thinner. Underline the effect of this change on the resistance of the lamp. Now, my dear, when it is said thinner, it means diameter is less. So area of cross section is less. And we know resistance is inversely proportional to area of cross section. If area is decreased, it means resistance is what? Increased. Resistance is inversely proportional to area. So answer is underline. So resistance increases. We scored 1 mark. State and explain effect of this change on the power of the lamp. Effect of this change on the power of the lamp. We will say that power of the lamp decreases. First mark you scored. Why decreases? No, I will explain you. As the resistance of the circuit is increased, this implies that current is decreased, and power is equal to I times V. So when current is decreased, so power will also be decreased for same voltage. So like this, you can write to score 2 marks. Even here, you can write voltage is constant or staying what? It is staying same. Okay, my dear friends, let's move forward. Next question is, state what is meant by direction of the field electric field. So it is the force, or you can say it is the electric force. It is the direction of electric force on positive charge. As we know, lines of force in electric field, they are directed from positive towards negative. So it is the direction of electric force, which can be the force of attraction or repulsion like this. So it is the direction of electric force on positive charge. Simple is that, only one mark. Then, my dear friends, figure 9.1 shows a pair of oppositely charged horizontal plates with top positive and bottom is negative. The electric field between the plates is uniform. Draw the lines on figure 9.1 to represent the uniform electric field. Add arrows to show these lines to show the direction of the field. So what to do? My dear friends, when it is written uniform, it means the distance between the lines is the same or constant. Now I'm drawing these lines. I will draw the lines like they are going from positive to negative, positive to negative, positive to negative, positive to negative, like this. I have done in hurry, but be careful in exam that the separation between the lines is equal. So this will show uniform. But still we are not scoring the last mark. 2 marks we have scored, but 1 mark is still left, and that mark is pointing the arrow, placing the arrows to point the direction of the electric field, which is always directed from positive towards negative. So 3 marks you have scored. Now, figure 9.2 shows a very small negatively charged oil drop in air between a pair of oppositely charged horizontal metal plates. The oil drop does not move up or down. What does it mean? It means it is at rest. If it is at rest, it means it is in equilibrium. So the resultant force on it is 0. Now what? He did not ask, but I'm just pointing it so that you can understand. This oil has a mass. So due to mass, it has a force of gravity which is vertically downward, that is its weight. Weight of the oil downward. Then it is negatively, so upper plate is positive, lower plate is negative, so it is repelled from the bottom and attracted from the top. So roughly, this is the electric force on it. And we will try to keep these arrows equal in length but opposite in direction. Now suggest in terms of forces why the oil drop does not move up or down. Already I have described you, arrows are drawn. So we can say weight of the oil drop is equal to electric force on it. It means the resultant force on this oil drop is 0 and it is at rest and it's not moving. Now, in terms of forces, this set does not move. Now, without losing any of its charge is still same magnitude. The oil drop begins to evaporate. State and explain what happens to the oil drop. Now see, upward force is still same. Weight has been decreased because the mass has been decreased. So now what will be the scenario? My dear friend, the scenario will be electric force has become greater than weight. This implies that now resultant force resultant force is upward and oil drop moves upward because upward force is greater. Then, my dear friends, next question is question number 10, that is on nuclear physics. An iodine isotope decays by beta emission to an isotope of xenon. Beta emission is there. State the number of each type of particle in the neutral atom of xenon. Neutral atom. Number of protons, that is 53, that it is a neutral atom, so it means the number of electrons will also be equal to 53. And what about the neutrons? That will be 131 minus 53, 11 minus 3, 8, 12 minus 5, 7. So they are 78, and 2 marks you have scored. State the symbol in nuclide notation for xenon nucleus, not iodine, xenon. We can say it Xe. This is 54 and 131. Same. Why so? Answer is like this. You will score 2 marks, but we can understand it by the equation, of beta decay. I 53, 131. It changes to xenon plus beta. Beta symbol -1, 0. So xenon should be 54. And here same 131. Why 54? Because charge should be conserved. So 54 minus 1, it will be equal to 53. And 131 plus 0 for nuclear number is equal to 131. So that is actually the reason we have taken it. In exam, you have to write only this. Now, the next question is a bit tricky. What is there, my dear friends? It is saying the background count rate in the laboratory is 30 counts per minute. A radioactive sample has a half-life of 50 minutes. In 50 minutes, the count rate is reduced to half of its original value. The sample is placed at a fixed distance from a detector. The detector measures an initial count rate from the sample, including the background, that is 310. So on the figure 10.1, plot the suitable points and draw a graph of count rate from the sample corrected for background as it changes with time. So first of all, we need to get the corrected counts. We need to get what? Corrected counts. So 310 minus 30, it is 280 counts per minute. Why so? 310 and background is 30. So corrected 310 minus 30, 280. So initial value is 280. But first let me write here what is represented by one small square, that is 100 minus 0 divided by 20. Because from here till here 20 divisions. So each small square represents 5 counts per minute. Each small square. So at 0 it will be 280. See, this is 200, 250, 260, 270. It means here it is 280. The starting value is 280. After one half life, what will be remaining? 280 divided by 2, it should be 140. So the half life is 50. Here we can write 50, then this is 100, and here it can be 150. So at 50, it should be 140. So see, 50 is here. This is 100, this is 150. So 140 here. Just two boxes below, because each box is 5. So 150 minus 10, 140. Then further we will divide it by 2. It will become 70. So at 100 it is 70. See, this is 100 in the center. This is 50, 55, 60, 65, and this one is 70. Then one more half-life, 70 divided by 2, it is equal to 35. So at 150, see 35, see 1, 2, 3, 4, 5, 6, 7. Why 7? Because each box is equal to 5, so 7 5s are 35. So my dear friends, in this way, we will be plotting these, marking these points, and now we are supposed to plot the graph. So, and it will be a line of freehand curve. It is a freehand curve. Like this. Then from here, my dear friends, something like this. Roughly you can draw. Something like this. You can use. So this will be the line of curve of best fit. I should still make it a little bit up. Not well judged. Like this. This is much better. So this way, line of best fit we can, a curve of freehand curve we used to call it, we can draw, and you will be scoring the 3 points. Now, dear friends, next question is about the logic gate, and it's no more with us from 2023 onward. It's not part of our syllabus, and the paper is done. I'm hopeful you have understood this all, and in case of any doubt or any particular year, past paper, and or a particular question, please don't forget to write it on the in the comment box on the YouTube channel, and you can ask me if you feel that this is helpful for you. So kindly don't forget to follow, like, and subscribe the channel, and share it with your friends and family members who are in Cambridge exams, taking external Cambridge exams. Stay blessed. Take care. Bye.